All right, let's talk about one of those classic math problems that trips up pretty much everyone, the order of function transformations. I mean, you know the moves, right? Shifting, stretching, reflecting, but getting them in the right sequence? That can feel like a total mystery.
I mean, it's the classic question, isn't it? You're staring at a function. You know you need to shift it, maybe stretch it, but which one do you do first? Because if you get that order wrong, your graph is going to be completely off. So, what's the secret?
And hey, if you've ever asked that, you are definitely not alone. This exact question popped up on Reddit, and it just perfectly sums up that frustration. It's such a common hurdle. But what if I told you the answer is something you actually already know by heart? Okay, so let's really dive into this whole puzzle. Because most of us, right, we're just taught a set of rules that feel totally random. They're just hard to remember, especially when you're staring at a test. I bet your textbook has a chart that looks something just like this. Step 1, do this. Step 2, do that. Horizontal shifts first, then reflections, then vertical shifts. It's just a list of rules you're supposed to memorize, and it feels completely disconnected from the actual math, right?
But what if we could just throw all that rote memorization out the window? What if we could use a fundamental rule of algebra, one you use literally all the time? Well, there is a simpler way, and honestly, it's pretty elegant.
Okay, so here it is, the big aha moment. The key to unlocking the whole order of transformations thing, it isn't some new complicated rule you have to learn. Nope, it's an old friend, PEMDAS.
Seriously, that's the whole secret. As one brilliant Reddit user pointed out, the order you transform a graph follows the exact same order of operations you'd use if you were just plugging in a number and solving. The secret is just PEMDAS. And you know what PEMDAS is, right? Quick refresher. Parentheses, exponents, multiplication and division, addition and subtraction. It's the absolute bedrock of algebra. And it turns out, it's also the bedrock of graphing, because what is a graph? It's just a picture of what happens when you evaluate a function at every single point. Okay, so let's break this down with an example. If you were just plugging a number in for x right here, what would you do? You'd follow PEMDAS, of course. Inside the parentheses, you'd multiply x by k, then add c. After that, you'd handle the exponent, the cube. Then you'd multiply the whole thing by a, and finally, you'd add b at the end. Well, guess what? That exact sequence, that is precisely the order you do your graphical transformation. All right, so let's put this logic into practice. We're going to start with everything that's happening inside the function's parentheses. All the horizontal moves that mess with the x variable directly.
So let's start with a nice, simple parent function. We'll use our old friend, the parabola, f of x equals x squared. Think of this as our clean slate, our before picture, before we start messing with it.
Okay, so looking inside the function's parentheses, you're going to have stuff being multiplied by x and stuff being added to x. Now, PEMDAS tells us that multiplication always comes before addition. And in the world of transformations, what's multiplication? It's your stretches and your reflections. And what's addition? Well, that's your shifts. And that right there, that is the why. It's not some random rule somebody made up. It's just PEMDAS. You handle the multiplication on x first, that's your horizontal stretches and reflections. Then you handle the addition or subtraction, and that's your horizontal shift. Simple as that. Okay, that takes care of the horizontal moves inside the function. Now let's look at the operations on the outside, the stuff that happens after the main function has already done its thing to x. And you'll see, the exact same logic applies. Once again, PEMDAS is our guide. Any multiplication happening outside the main function, that's our vertical stretches and reflections, that comes before any addition happening outside, which is our vertical shifts. See? It's perfectly consistent. So let's put it all together. Here's the complete unified order. You work from the inside out, always following PEMDAS. So you do the horizontal stretches and reflections first, that's inside multiplication. Then the horizontal shifts, that's inside addition. Then you move to the outside, vertical stretches and reflections, outside multiplication. And finally, vertical shifts, outside addition. This one framework, it replaces that whole long list of steps you had to memorize. Now, there is one super common trap where this whole system seems to fall apart. But if you just remember one golden rule, I promise you, you will never get it wrong again.
So take a look at this tricky one. This came from that same Reddit thread. You see a function like y equals f of 4 minus x. What do you do first? Do you reflect it because of the minus x, or do you shift it because of the 4? This is exactly where people get stuck.
The first instinct for a lot of people is to see that minus x and reflect the graph over the y-axis. Then they see the plus 4 and think, okay, shift left by 4. Makes sense, right? But it's wrong. That will give you the incorrect graph. So here is that golden rule I was talking about. You have to always factor the inside of the function first. You need to pull out the coefficient of x. So when we take that 4 minus x and rewrite it, by factoring out a -1, it becomes negative x minus 4. And just like that, the true transformations are revealed.
See? This is the power of factoring. That negative sign out front, that's our reflection over the y-axis. And the x minus 4 on the inside, that clearly tells us to shift to the right by 4. All of a sudden, the confusion is gone. The order is crystal clear.
So here it is, your new toolkit boiled down to just 2 simple steps. Number 1, always factor the inside of the function first. And number 2, apply the transformations by just following PEMDAS, working from the inside out. That's it. No more confusion, no more guessing.
You know, this really just goes to show you that so often the most confusing sounding rules in math are really just simple, fundamental ideas in disguise. Which kind of makes you wonder, right? What other complex topics out there could be unlocked if we just looked for the simple core idea hiding underneath? Something to think about.